Hi and welcome back. My name is Dominic. I'm one of the founders of Duende and creators of Identity Server. And this is the second video, which is an excerpt from our 2 or 3 day training we typically do at conferences, which you can find on the link below. So in this video, which is the second part, we want to talk about now adding additional authentication methods to our simple, forms login based application that we wrote in the first video. So in other words, basically what I want to do is add a new link here, sign in with Google, for example, to our login page to give the user basically two options. How they want to log in, with a local account or with an external authentication provider, and that is just an example of any external authentication provider you might want to use, and a couple of challenges that come along with starting to support external authentication methods and a couple of solutions to these challenges. Okay, so that's basically what we want to cover in this video. So let's get started. Okay, before we start writing some code, one slide promised about a little bit of theoretical background, what we're doing here. In the last video, we talked about the authentication handler concept in ASP.NET Core, which basically is an abstraction or an encapsulation of an authentication method, right? And we've seen the cookie authentication handler, which takes care of issuing a cookie, validating a cookie, and so on and so forth. Now, in that hierarchy, there's another base class, which is called the remote authentication handler, and that is designed to provide common features and abstractions for dealing with authentication systems which are external to your application. They are remote, okay? And the way these authentication methods typically work is that you send the browser and the user to that external system. That external system is doing its work, and then once this is done, the external system will call you back, and on that callback, you have to run some code to validate whatever response data came back from this external system. That is kind of like how not all of them, but very typically remote authentication works on the web. Okay, and that is exactly what this remote authentication handler is designed for. So we still have the same challenge method as we had before for the cookie handler, but this time instead of sending the user to a local login page in the application, it sends the user or the browser, the user agent, to a remote endpoint on that remote authentication system that is typically like a protocol endpoint that takes some parameters and then based on that shows a login UI. Okay, and once that external system is done, it will send the user back to a callback endpoint, which is implemented by the remote authentication handler to then process whatever authentication response came back from this external system. So both of these things are basically part of this remote authentication handler. Some remote authentication systems also support like federated or remote sign out, meaning you can tell them that your user has signed out of the local application and then let them know that they might want to sign them out as well in the remote system. So these are kind of like the 3 things that make an authentication handler a remote authentication handler. Now, ASP.NET Core ships with a couple of remote authentication handlers. First of all, and I call them proprietary providers because they typically don't use a standard protocol, or they started at not using a standard protocol. So Microsoft created like specific providers for them to basically surface their specific behavior or specific features that they might have, and that is Google, Facebook, Twitter, and the Microsoft account. Now, there are many remote authentication systems out there, some of them more standards compliant than others, but most of them, to be honest, like especially in the social, whatever that means, space, they often use some sort of dialect of OAuth 2, in one way or another, okay? And because there are so many flavors of them, it's hard to produce one remote authentication handler which works for all of them. So there's actually a community project I want to make you aware of, which is this one here. which has many implementations for popular authentication systems. So when you go there and you go to the source and you see that they have things like, I don't know, Adobe and Amazon and Basecamp and Battle.net, of course, right? And you name it, right? Dropbox, LinkedIn, GitHub, going on and on and on, to Untapped, for example, right? And so on, right? So basically, the gist here is there are many of those, and all of them are not quite compatible with each other. That's why there is a dedicated handler for them. The good news is, once you know how one of these handlers work, and that's what we're going to do in this video here, you know how they all work. And that's that was the design goal of that abstraction. That all you need to know is how to deal with the public API service of the handler, and that is basically like the challenge method, right? And the sign out method, and all of the methods we already covered in the last video. And then under the covers, they do their whatever they need to do, right? So that's the proprietary providers. And then there's another bucket, if you like, for standard authentication protocols. And there are pretty much, that there were 3 big authentication protocols out there used in the industry, which is OpenID Connect, WS Federation, and SAML, right? So SAML is probably the oldest and a very commonly used one, which is, still important, but OpenID Connect is becoming by far the most important of these protocols. And then there's WS Federation, which is really not that important, to be honest. But there's a popular product from Microsoft called ADFS, which used that, for example. So if you have to integrate with this, WS Federation is an option. Okay, so let's jump into the code very quickly to see what we have. So we have a very simple, .NET 7 based ASP.NET Core application, and that's exactly how we left the solution last time. So we have set up our cookie authentication, we have some authorization policies, and that's it. And our application is protected globally for to not allow unauthenticated users, besides a couple of pages, for example, our index page, where we, allowed this explicitly. So as I said, our goal for this video is to basically implement this sign in with Google functionality. So let's do this. So when we look at our account page, let's go to the login page. You see here basically there's a link, sign in with Google, and that basically does a redirect to a page called Google, and we are passing on our return URL so that later on, when everything is done, we can send the user back to wherever they came from in the first place. So we're going to add a page, a Razor page called Google, and that's what we're going to do. This will not really have a UI. We're just going to use our code behind here to basically write some code against the authentication system when this URL gets invoked. And at this point, the user is anonymous, right? So we have to allow anonymous access to this method. So what's the first thing we have to do? Support for Google authentication is not part of the core ASP.NET package. So we need to add a NuGet package here. So we add a package reference here, and the name is Microsoft.ASP.NET Core.Authentication. And then you see here there are lots of packages to choose from, and the one we want is called Google, and the version is 7. Okay. So we're going to add this first. And basically by adding this package, you will get a new extension method here for our add authentication API. So now we can say add Google. Okay. Same rules apply here. I like to give the Google, the handler a name, right? And then we can pass in Google handler specific authentication options. So the first thing, and that's Google specific, is that Google wants you to register your application with Google before you can use their authentication services. I'll show you in a second how that works, but ultimately what they will give you in response for registering your app with them is a client ID and a client secret. At least that's the approach used with this authentication handler. So that's one thing. Then, we're going to do this in a second. The next thing that you have to understand is, I mentioned earlier that a remote authentication handler needs to implement an endpoint that can receive the response coming back from Google, and that's what they call the callback path. Okay, so all of the logic for handling the callback from Google is inside the remote authentication handler. There's no code you have to write for that, but you have to configure, or at least you have to know that this path exists and where it is. And it turns out, by default, this path will be sign in -Google. Okay, you can change that path if you want to, but that's the default value. So that means we don't have to set this here, but it's good to know that this thing exists. The next important thing to understand is that the Google handler itself only implements the Google protocol, meaning like how to get to Google, right? And how to validate what comes back from Google. Once this is done, basically the next step would be to start a session for that user, right? This is the session management part, of course, is not part of the Google handler. It's already implemented in our cookie handler. So ideally, or what you should be aware of is that the Google handler will hand off all of the session management to another handler once the job is done, right? And that you can configure here on what they call the o.sign-in scheme, right? So you could basically, if you want to be very explicit, say, okay, so once you are done, call a handler named cookie, which is this name here, to then sign in the user and start the session and so on. Again, in this situation here, our default scheme is already set to cookie. So again, if we omit this configuration setting, it will use whatever is configured to be the default scheme. Okay. I'm mentioning this because, if you are not aware of these little details here, there's a lot of magic involved, yeah. But there is no magic. It's really pretty simple. That's how you tell the handler to listen for callbacks on this URL, and this is how you tell the handler to then pass the result of that callback, which ultimately will be a claims principal, to whatever handler then that can start the session for the remote user. Okay, cool. So that's the configuration we need to do. Now let's, as a next step, register our application with Google. So you have to go to the Google Developer Portal to make this work. And basically you register your application here. You go to console.cloud.google.com, then you can register an application, and you can basically also configure to which APIs and services should this application have access to, and so on. And then ultimately you need to go to this credentials page. Here's my demo client. And then you see what they need from you is to tell them, okay, so once we are done with authentication, where do we send the user agent back to? And you see my application is running on HTTPS localhost 5001, and that here sign in -Google, that's exactly the callback path that is the default value for my remote authentication handler for the Google authentication, okay? So in other words, that value here must match this value, okay? And as I said, that's the default value here. So I'm going to leave it like this. Cool. So, and the last thing we need to do is then, once we have set this up, here are the client ID and the client secret that Google has created for us. So we're going to go here, copy the client ID in here, and the client secret in here. Cool. So that means now, from a configuration point of view, our Google Authentication Handler is set up. So how do we invoke it now? So let's go back to our onGet method. Okay. So remember, our login page is going to invoke the Google page and going to pass the return URL parameter, meaning we're going to expect to get a return URL here. Okay. So and then we already know that there are these extension methods on the HP context that we can call. So the first thing we need to do is we need to make this async task I action result. Okay. And then we can do await HP context, right? Dot challenge async, for example. And you've seen that, you know, when I omit the parameter on the challenge method, then it will use the default scheme, or we can use this method to explicitly invoke handlers. Okay. There's even one easier way to do that, which is more like a, you know, like a Razor Pages / MVC style way of doing it. And they basically Microsoft implemented action results, and one is called the challenge result, and we can pass in the name of the handler we want to invoke. Okay, in this case we don't even need this anymore, so we can just do basically that. Sorry, like this. Okay. Now the last thing that's missing is we have to tell the Google Authentication Handler where to go to after the authentication is done and after the session has been started. And that's our return URL parameter. And as we know from last video, this is sensitive data in the sense of that we have to validate it, right? We don't want to accept arbitrary return URL strings. Otherwise somebody could abuse our page to do a redirect to an arbitrary different page, and that can be used for phishing attacks and so on. So last time on the login page, I showed you the local redirect method, which does exactly this. It checks first the return URL if it's a local URL, and if that's the case, it does the redirect. Otherwise, it will throw an exception. Okay, and a more defensive way of doing this, you could also do something like this. If URL is local URL, right, and that basically instead of throwing an exception, you now get a, you know, basically a true or false here, and then it's up to you really what to do with this. If you go back to a safe URL, or if you want to do some logging here and tell your admin that maybe somebody is playing around with your URLs, or, you know, we just throw an exception. Invalid return URL. That's just demoware here. You know, don't do that for a real application. But ultimately what that means is now beyond this point, we can trust that this return URL is local. Okay. And the way we pass additional parameters to our Google Authentication Handler is by creating this thing called Authentication Properties. And there's a thing called the redirect URI, and that's our return URL. Okay, and then we're gonna pass this props here. Okay, so let's have a look what's happening. Let's run this. Okay, so here we are. I'm still here in the Google thing. Let's log out from Google. That makes that demo more fun. Okay, cool. So we are here. I'm hitting the secure page. This brings us to the login page. Now the user has the options, right, of logging in with a name and password or using the sign in with Google. So now if I click the sign in with Google, that brings us to the Google endpoint. This will challenge the Google handler, and the Google handler's challenge implementation should send the user agent to the Google login page. That's exactly what happens, right? So now I can here pick my account, and we log in. And now before I hit enter, lots of things will happen now at once. Yeah. So basically, Google will validate my password. If that's correct, it will create some sort of authentication response. That authentication response will get sent back to whatever is configured to be the callback path, right, on the remote handler. Then the remote authentication handler will validate that authentication response, and then ultimately create a claims principal, and then hand that claims principal to our cookie authentication handler to call sign in on this, right? That's the whole thing, the whole purpose here, that ultimately somebody signs in that user coming from Google. And then, as a last step, the Google authentication handler will do a redirect to whatever we set to as the redirect URI, which is our secure page. And then our secure page will again simply just print out the claims of the currently logged on user. Okay, so that's what should happen. Let's see if it does. Huh. And I do. Which is actually a really nice example, right? How you can, in your application, make use of, all of the nifty security stuff that other authentication services has implemented already, and you don't have to if you rely or trust them for doing the work. Okay? So yeah, cool. So we are back on our secure page, and as I said, the code hasn't changed here. All our secure page is doing is printing out the claims of the currently logged on user. Okay, and as you can see, weird things are here on the screen. First of all, so there are these really long claim names here, and you might have come across them in the past. And the backstory of that is these are really just string constants, yeah, like. And the real claim is called name identifier, but the reason why this is an HTTP schema and has the word XML in there and so on is basically these constants. They come from the old SAML WS star style specifications, like long time ago. They got implemented in WCF for the very first time, and then ported over, and Azure AD started using them, and pretty much Microsoft is stuck with them because if they would change them now, stuff would break, basically. Yeah. But fast forwarding to 2022, they are ridiculous. I mean, you don't need these ancient claims anymore. And we're going to fix that problem in a second. I'm just going to tell you that's where they come from, and what I encourage you to do is to transform those claims into whatever claim types your application wants to use. So for example, the name identifier is a really old name for the SUB claim, the subject identifier, right? There's the name claim and the given name claim and the surname claim and the email address. So they all have modern counterparts in modern specs, and I'll show you in a second how to transform them in multiple ways. And as a side note, of course, these claim types do not come from Google. Google does not use these old claim types, but the Google handler was written by Microsoft, and Microsoft thinks or thought that they do you a favor of taking whatever claims coming from Google and transforming them into Microsoft's preferred claim types. This has been discussed a gazillion times on the issue tracker, and I still think it's the wrong approach. Many people agree, but it's too late to change that now again because of backwards compatibility. Okay, so there are two things we have to discuss. The first of one will be how do we now turn these claims into something that makes more sense for our application. And the general way of doing that, or one of the options you can do that, is by handling events on the authentication handler itself. So all authentication handlers have this property called events, okay? And they are basically, there's a class, and as you can see, there are methods here that you can implement, or events that you can implement. And one of them, which is not really like the most self-explaining name, is called onCreatingTicket, and if you look at the help, it's invoked when the creatingTicket method is invoked. Yeah. So basically, what you need to know internally, there's a data structure called an authentication ticket that gets passed around, and when they create, and that authentication ticket has, for example, the claims principle on it. Yeah. So and this authentication ticket is the thing that gets passed to basically the session management. Okay, so and by handling this event, yeah, you can basically look at the contents of that ticket and other things, and here you see one of the properties here is the principal. Okay, so that's going to be the principal that will get passed on to the cookie handler to call sign in. Okay, so in other words, you can change that principal now in any shape or form as you like. So if you want to transform that name identifier claim to an SUB claim, you know, feel free to change that. Create a new principal that has only the claims that you care about in the format that you like, right? Or maybe you need additional claims about that user, so maybe you go to a database and take the SUB claim and add more stuff, right? Basically, long story short, whatever principal you create here in this event will be the one that gets signed in to the authentication handler. Okay, so that's an important event. So let's just recap what we did before we talk about other stuff. So you've seen that basically whenever you do an external authentication, it has two phases, right? The first phase is the challenge phase, where you say basically call challenge and pass in the name of the authentication handler that you want to invoke. And then the handler's challenge async method gets invoked and sends the user agent to whatever remote location that is necessary to implement this, okay? And then now the browser is at the external provider, waiting for the user to sign in at the external provider. Then the callback happens, meaning the external provider calls back your local application on the callback path, right? And then the authentication middleware figures out, based on the callback path, which authentication handler is responsible for handling the response. And then basically does whatever protocol post-processing is needed to validate what came back from the external system, and then create a claims principle from that, and then hands off control to the whatever handler you configure to be the session management handler, typically the cookie authentication handler, to call sign in, and then ultimately returns to the final URL. Okay? And that is basically how all of the authentication handlers do work. Okay, and now you could imagine creating a login page with sign in with Google and sign in with X and sign in with Y and so on. It's always the same. Okay, now we're going to end this video here and make a second part to discuss the more advanced features, but just as a cliffhanger, if you like, discuss some problems that are not easily solvable with this approach here. So there were two things here. First of all, as you can see, what we basically created now is an application that takes an arbitrary Google user account and signs them into our application, right? That's maybe not what we want, right? Maybe you know, like the Google thing is just an authentication method. Just because you have a Google account doesn't automatically mean you are a user in my application. Maybe there is some more involved processing necessary. Yeah. Very typically, I would recommend that you create your own user subject identifiers and just map the external identifier to your local identifier, so that you can hang off your specific claims, you know, your custom business data, maybe roles, maybe whatever, off of your user account. Yeah. That is not working with this approach here, because the user is already signed in. It's too late, right, for doing anything to inject logic before the user is actually a legitimate user of your application. Okay, so that's one thing here. The other thing is maybe your onboarding process distinguishes between the use case of a first, like a first time user and a returning user. So the first time user, maybe a completely different logic is necessary. Maybe you need to show additional UI. Maybe you need to, I don't know, maybe he needs to accept your end user license agreement, or maybe they need to enter a credit card, all kinds of things that could happen for the very first time an external user logs in that need to happen in a certain way before you can actually accept that user as a user of your application, right? And then maybe for returning users, that logic is different, probably simplified, right? That you can just log in and you already have all the data you need. Now, with this event-based approach here, this is not going to work, because here you can't basically stop the flow. This would be like in the middle of a protocol interaction. You can't just show arbitrary UI and then continue the flow. So this eventing-based approach is useful if all you need to do is maybe do some in-memory, transformation, get some additional data, change some claims, don't need to show a UI to the user, things like that, yeah? But as soon as you have a more advanced use case, this is not going to happen. And there's a pattern for that, which we call the callback, which we talk about in the next short video. So see you over there. Bye.